Thank you for attending today's webinar. CivicSolar and GS Battery have teamed up to tell you about advanced lessons in solar plus storage. My name is Madeline Ackery, and I am an account manager at CivicSolar, and today's host, Eric Gallant, is the Director of Business Development at GS Battery, and he will be today's presenter. CivicSolar and GS will present current trends and developments in the solar plus storage market. We will have about 5 to 10 minutes for questions and answers, and these slides will be available after the conclusion of the webinar.
Thank you, Madeline. As Madeline mentioned, my name is Eric Gallant. I'm Director of Business Development with GS Battery, responsible for renewable energy projects and energy storage throughout the Americas and the Caribbean. And I appreciate everybody dialing in today, and I'm looking forward to talking to you a little bit about energy storage and PV and how those two technologies can work together to deliver some additional value to your customers. So I'm going to talk a little bit about the value of energy storage, why it's important. You know, if you're in this industry, I'm sure you've been hearing a lot about batteries and energy storage and what we can do with these technologies. I'm going to go through some case studies and talk about how we've applied those technologies to a few projects, and then spend a little bit of time talking about GS Battery, who we are, and what technology we bring to the market, and why we're a good choice to work with. So there's a great graphic here from the Rocky Mountain Institute, which really lays out 13 benefits of energy storage. And it segments it out by 3 different positions within the electrical distribution scheme. The first is end users, second is utilities, and the third is transmission and distribution. We're really going to focus in on end users. There's a whole different set of applications for energy storage related to what the utilities need to do and what sort of advantages the transmission and distribution grids can gain from energy storage, but we're really going to focus in on end users, primarily residential and commercial industrial customers here in the US. So for that type of customer, or what we call a behind-the-meter customer, there are really 4 key benefits for end users. And the first one is one that a lot of people are familiar with batteries. It's a battery backup. So if you lose all your sources of energy, you can still have some energy stored in your battery bank to allow you to keep operating normal operating mode. The second is PV self-consumption. So rather than maybe exporting your energy from PV back onto the grid, batteries will allow you to store that energy locally and use it again at a time when maybe the sun isn't shining. Third is peak demand reduction. For a lot of our commercial and industrial customers, this is a huge driver. Some of the utilities, and it varies from location to location, will charge their commercial and industrial customers a much higher rate per kilowatt hour if they exceed a certain peak demand threshold. And you may exceed that threshold for only 15 minutes, but you'll be charged for the whole month at that higher rate. Some of the statistics I've seen indicate that in California, a typical commercial or industrial customer, 30 to 40% of their monthly power bill is peak demand charges that could be reduced if they were able to find a way to reduce that peak demand and stay below that threshold. And finally, similar to peak demand in some ways is time of use shifting. Through energy storage, you can, without changing anything about the way you operate your business or your home, take advantage of that difference in rate to your benefit by charging your batteries when the rate is really low and then discharging when the rate is really high and having a lower overall operating expense. So a little bit more about energy storage. Because of all those benefits throughout the grid, we see a really huge increase in the amount of energy storage projects that are getting the green light and getting lit up. This is a graphic from GTM Research. They say that in 2016, finished up the year at about $320 million nationally for energy storage projects. Now this includes residential, commercial, industrial, and utility scale. They're expecting by 2020 to be 10 times what it is today and up to $3.3 billion in the US alone. So you can see we're starting to see that significant upswing, kind of like we saw in solar a few years ago, where it's becoming more and more widely adopted as more and more people are recognizing the benefit of the technology. One of the things that's driving that expected growth in energy storage is just like there was in solar, there are state and federal incentives that is really driving the market and adoption of the technology in different regions. I'm not going to go through each one of these, but as Madeline said, we'll make the presentation available to you. But what I want you to leave you with is the idea that in a lot of states, there's a lot of money going towards funding energy storage projects at the behind the meter level. So there's definitely a lot of money being spent in front of the meter with the utilities for large scale energy storage projects, but there's also a lot of money that's becoming available at the residential level. I was just talking with Madeline and the other folks at CivicSolar yesterday about some legislation that's going through the state Congress there in California regarding the SCHIP program. Really great program, really geared towards improving the adoption of energy storage in the state of California. And we're seeing similar programs in Arizona, certainly Hawaii, definitely in the Northeast with New York and Massachusetts and Connecticut, and even some in Florida and Colorado. Encourage you to go look in the states where you are and see if there are similar programs that are being launched. So given that, I'd like to talk about a few examples of how we've been using energy storage plus PV to accomplish some of those four key goals for end users. And the first project here is an off-grid project up in Alaska. And this was a really great project to work on, really beautiful scenery, really amazing remote location. This is a fishing lodge that's used for fishing in the spring and heli-skiing in the fall. It's completely off-grid. It was really important for the stakeholders involved in the project to have a green solution that was in keeping with the pristine nature environment around the lodge. As you can imagine with a site like this, they spend a lot of time on generator. Fossil fuel generator was their primary source of power before this project. And a generator in a remote location like that can be an expensive proposition. It takes a lot to get fuel to this site. The only way to access the site was by the plane that you see here in the foreground that lands on the lake, or by helicopter. And bringing a bunch of diesel fuel up to the lodge by plane was expensive, and then maintaining the generator. And then there were the emissions problems with and the noise problems with the generator. So they really wanted to minimize the amount of time they spent on generator. They also wanted to have a solution that wasn't so complex that it couldn't be easily maintained by local personnel. And they needed something that was going to be low operating expenses. So what we came up with for our technical approach was 192 kilowatt hours of energy storage. It was configured for daily discharge. And the battery that we chose was 100% recyclable. So all the materials that are in the battery can be sent to the smelter, reused for a next generation of batteries, but none of them would end up in the landfill. Being Alaska, of course, we also needed a battery with really good low temperature performance. We needed something that was maintenance free to reduce that operating expense and to be locally maintainable. And we needed something with a long warranty. So the battery we chose for this one had a 10-year warranty and a 15-year design life. What was also important to this customer was to be able to peek in on the performance of their battery. So we installed a battery monitoring system that measured the voltage of every cell in the system, the temperature of every cell, and the current into each string or each module of the battery. And from that, we're able to determine the state of health and state of charge. There's a local graphical display which shows the customer all of that information if they're standing in front of the battery. But there's also an online portion of that where the data from the battery stack is collected in the cloud and can be viewed through over any time period. So with a 10 or 15-year battery, you could potentially be looking at 10 or 15 years worth of cycling data on that battery stored on the web. So a really powerful tool to allow the customer to remotely access their battery and understand the conditions, as well as track the performance of the battery over the life of the battery. The next case study is in New York City. And this is a little bit of a different project. This is a multi-tenant housing facility that was online. It was in the area affected by Hurricane Sandy. As you can see in this picture here, there was water running through the streets of this area of New York. They were really hit hard by that storm. Now, they had a photovoltaic system there, and it didn't really help them much when the utility power went away. And in talking to a lot of the people there, it was a bit of a shock to them, because they told me they were sitting in their house or in their apartment in the dark as the storm passed, and waiting for the sun to come up after the storm, because they were confident that if the sun came up and hit those solar panels, they would be back into energy. And what they realized pretty quickly was, even with the sun shining on the panels, without that utility reference signal there, they were still not up and running. So they recognized a real need for increased energy resiliency, and that affected all the way from the lighting in the apartments and the comfort loads in the apartment through life safety loads. They needed lighting in the hallways, lighting in the stairwells, emergency power for the elevators, so that if the power went away, the elevators could be brought down to their lowest level. Other life safety critical loads. And there was also an opportunity in this case for them to participate in one of those special programs that I talked about on the previous slide, that's sponsored by the state, which allows customers to participate in a demand response program, or a peak demand reduction program. So some of the objectives of this project were to allow them to operate in an islanded or off-grid mode if the utility went away, provide that backup power, that one of the four key benefits of energy storage that we talked about. We allowed them to integrate some additional solar, so they could add more solar to their facility, harden those critical life safety loads, and allow the participation in that demand response program. And you can see from the picture here, looks totally different today, but really great to see that area bounce back from what had been a really devastating storm. There's one more project objective here that I think is really the most important one for this project. And that's, if any of you have ever done a project in New York City, codes and regulations, or codes and standards in New York can really, really bog you down. For this project, we had to comply with local and national codes, and a bunch of different authorities having jurisdiction that were really concerned with, just watching the news, seeing the videos online of batteries in laptops, batteries in cell phones, batteries in hoverboards that were catching fire, going into a catastrophic failure mode, and as a result, harming people or even burning down buildings. There were a couple cases where these hoverboards had actually burned down people's garages. So as you can imagine, the fire marshal in the city of New York was very sensitive to that type of possibility. And so we ended up having to comply with a number of different authorities having jurisdiction, including UL, the National Electrical Code, the Electrical Inspector for the state of New York, an organization called NYSERDA, which controls energy and energy storage in the state of New York. Of course, the National Fire Protection Code, the Fire Department of New York City, the International Fire Code, because there were some requirements around hydrogen accumulation, which is a possibility in some battery installations. And then finally, the New York City Department of Buildings, which really had a supervisory role over bringing a lot of these different authorities having jurisdiction together under one area of responsibility. So you can see complying with all of these different regulatory bodies, codes, standards, and listings was a real challenge. But nevertheless, we were able to take the project to the finish line. And in each of 3 buildings, we installed between 96 and 128 kilowatt hours of energy storage. Again, set up for daily discharge cycles, and also set up to discharge as needed for demand response. And of course, the UPS function, if there was a loss of utility power. In this case, we did a lower voltage DC bus. This is a standard 48 volt DC bus, which I'm sure a lot of you guys see if you're familiar with any of the inverter chargers that are common in the marketplace. And again, cell level battery monitoring, very important in this case. Absolutely needed to have the voltage and temperature monitoring that allowed the operator of the building, the building superintendent, to have visibility into what the battery's state was. Needed to know the current that was going in and out of the batteries, as well as state of health, state of charge, and that remote access and online data storage and trending. One thing that was unique about this project that we don't normally do was an additional special thermal runaway monitoring system. As I mentioned, they were very concerned with some of the failure modes that they had seen from other battery technologies. And so we developed a special IFC compliant battery monitoring system that would actually open breakers and change the breaker lineup of the electrical system in the event that any of the batteries became overheated. So a special third layer of safety monitoring on these batteries. Our third case study here is a residential project. This is a net zero residential facility, a residential building in Boston. And the customer here was very interested in grid defection. They didn't want to cut their connection to the grid as much as they wanted to reduce that connection to the greatest degree possible and rely on grid only as a backup in case everything else failed. Now they're doing this in part to reduce their residential carbon footprint, of course, to eliminate as much as possible the bills from the local utility, take advantage of some local tax incentives, again, going back to those incentives that we saw on the earlier slide from the state of Massachusetts. Excuse me. Improving their overall responsibility. And they really wanted to use this house as a demonstration platform for what's possible by combining PV and energy storage in a residential format. So in this case, we did a little smaller scale project. It's 48 kilowatt hours of energy storage, again, configured for daily charge and discharge. Really set up for self-consumption mode, not exporting any energy back onto the grid, only storing your excess PV for use at a later date. The UPS function or battery backup. And again, another low voltage project with 48 volts DC on the DC bus. The same cell level monitoring with voltage, temperature, current, and state of health, state of charge. And this is the basement of the customer's location. You see here, they've got a really compact energy storage system. Fortunately, nice high roof in the basement. We were able to put 48 kilowatt hours just in a corner of the basement, and he was able to set up his power conversion gear actually just to the side of the energy storage system. So a really nice project. We're still looking at some of the data, but so far it looks like they'll accomplish their goal of being net zero, and really a great project as a reference for folks that are looking at doing a residential project. Our final case study of the day is a little bit farther afield. This is a one that we feel really demonstrates the environmental benefit of PV plus energy storage. This is the Capaui Lodge in Ecuador. Now this is an ecotourism lodge that's located right in the Amazon rainforest. It's an amazing place where people can come, spend some time, really getting a look at undisturbed environment that for a lot of people are very concerned as being threatened. Unfortunately, the entire site, just like the Alaska site, was dependent on fossil fuel generators for power. That posed a lot of unique problems in the Amazon rainforest. The noise pollution, this is something that I learned through the process of this project. The noise pollution from a running diesel generator can actually upset the predator-prey relationship of the animals in the forest. The operator of this lodge was telling me that the predator animals in the forest would wait until the generator started, and then they would start hunting because the sound of the generator would actually mask their approach from the prey animals, which I thought was a really fascinating thing to be happening. And not to mention the standard air pollution and other pollution associated with operating a diesel generator. And again, like Alaska, some extremely high operating expenses associated with operating that generator, fueling it, and maintaining it. You'll see on this next slide, this canoe is how they bring guests to the hotel, how they bring all their provisions, and in fact, how our battery system was brought to the site. Each of the batteries that was used in this case is about 150 pounds. So one or two batteries per canoe was the most we could do. Now, interesting side benefit that we were able to achieve on this project is these canoes had operated on outboard motors, which, similar to diesel generators, have an emissions issue. But the outboard motors exhaust underneath the water line of the river. And so they were actually pumping a lot of pollutants into the water of this really pristine river environment. What we were able to do was switch those outboard motors into electric motors. And those electric motors were charged by the energy that was stored in the batteries, which was recharged by the energy from the solar array. So a little ancillary benefit that the customer hadn't actually counted on there. But the overall project objectives were really similar to the three case studies that you've seen before. Reduce the overall consumption of fossil fuel, integrate additional renewables, improve the site power quality and resiliency, improve the customer experience. So the customer, and in this case, the customer I'm talking about is the guest of the Eco Lodge, who didn't have to hear the sound of the generator anymore. Decrease the impact on the sensitive ecosystems, being both the jungle environment and the river environment, and reduce the operating expenses associated with that generator and diesel fuel consumption related emissions. So our technical approach there was, again, 48 kilowatt hours of energy storage set up for daily charge and discharge cycles, self-consumption only, battery backup in case the generator isn't online, and a 48 volt DC bus. You can see a little bit of a different power conversion package here. Back up for just a second. There really wasn't as much of a need on this one for the energy monitoring system or the battery monitoring system because there's really no internet connection to upload the data to the cloud. Now, the thing that every one of these solutions had in common was we use the same battery technology. In this case, it's the GS Battery SLR line of advanced lead carbon batteries. And if you're not familiar with lead carbon, it kind of gets lost in the buzz surrounding some of the more exotic battery chemistries. But recently, there have been a lot of advances in lead acid battery technology. And most of them are around materials science. And we've been able to apply some nanocarbon structures to the negative grid of the battery. And it's really eliminated one of the main failure modes of a lead acid battery, which is sulfation. By having these nanostructures on the negative grid, The size of the sulfate crystals is restricted to the cavity formed by the nanocarbon structure. The nanocarbon also increases the reactive surface between the negative grid and the electrolyte, which allows us to charge and discharge faster and have a much higher cycle life on these batteries than has ever previously been seen with a lead acid battery. This battery will actually do 5,000 cycles at 70% depth of discharge, which is really unheard of for a lead acid battery. That allows us, if you do the math, 5,000 cycles with a cycle a day is about 14 years. That allows us to do a 10-year warranty on it. It is a sealed, maintenance-free battery, so there's no watering of these batteries. There's no concern about outgassing or buildup of flammable gases. It's inherently safe battery chemistry technology. None of those catastrophic failures that the people in New York were so concerned about. It's 100% recyclable. A little bit about the battery itself. They're 2-volt cells. They're available in 1,000 amp hour and 500 amp hour modules. It's UL listed, and most importantly, this is not something that we're currently putting people on a waiting list or giving them long lead time items. This is a battery that we have in inventory here in the United States and is available through CivicSolar. The SLR is sold as a kit. So instead of buying individual batteries, we also provide the battery rack, all of the battery interconnects, a bunch of safety features that prevent inadvertently touching a live electrical system. Comes with the overcurrent protection, and optionally it comes with a cell level battery monitoring system or potentially a seismic zone 4 configuration, which some of you that are in Southern California and a few other areas of the country are sensitive to the requirements of seismic zone. And they're available in 24, 48, and high voltage configurations. So that was the technology that we used for those 4 energy storage projects. You know, one of the things that's one of the constant conditions within PV and energy storage is there's a tendency for companies to pop up, be maybe really well funded with venture capital, some new gee whiz type of technology, but before you know it, they're gone and bankrupt. I want to really stress that that's not the type of company that GS Battery is. I know that we're not as well known in the United States as some of the competitors, but we're actually the second largest battery manufacturer in the world. We've been in business for over 100 years, very corporately stable. It's everything that you saw in this presentation. It's all manufactured in Japan. Most rigorous quality control and management standards that you can imagine to keep the quality at the highest possible level. But nevertheless, we still have a global footprint. Lots of project experience throughout the Americas and the Caribbean. Product availability, and I think one of the important features that we have is here in the States, we've got a lot of really experienced engineers and technical support people that can help people with their deployment. A lot of people who are even really familiar with PV installations are still getting the hang of some of the energy storage installations, and so we can help guide people through that with some really experienced guys who have been out in the field at each of these sites and a ton more, and know these systems inside and out. Also want to point out that although I focused on the SLR lead carbon battery in this presentation, we offer a full line of energy storage batteries, modules, and accessories, including a standard lead acid battery, 8D, 4D, which you may be familiar with. Of course, the lead carbon advanced lead acid battery, also NiCad, and a full line of lithium ion batteries. So really one-stop shopping for 4 different battery chemistries, global footprint, and a lot of technical capability to help you guys out with some of your projects. So that's my presentation. I think we'll open it up now for some questions. And there's also some contact information here for Madeline.
Hey, Eric. So we've been getting a few questions rolling in, and I will, if you can see them in the questions dashboard, I can also just relay them to you. Let's see. For case study 3, it looks like it was AC coupled. What happens if a customer kills their batteries and the Sunny Island shuts off? Is there a self-recovery option?
Yeah, actually, that's a great question. A lot of that is I'm trying to remember which one was number 3 now. Let me go back to that. Yeah, we actually have a Sunny Island system here at our corporate office in Atlanta. We've got 3 Sunny Islands that we were actually just looking at yesterday afternoon. One of the great things about that product, it's probably not the most advanced product now, but you can really configure a lot of different parameters on that inverter charger, including exactly when it shuts down battery, when it will bring the batteries back up. We were actually adjusting the charging current set point on that inverter here at our site last night. So a lot of capabilities, a lot of ways to configure that system for optimum performance.
Awesome. Thank you. One of the questions that we also got was, do you support projects in Canada? I can speak to that a little bit. We do support, our account managers will support customers in Canada. Depending on if you are in British Columbia or Alberta, you'll most likely be with an account manager in Oakland. If you're in Saskatchewan or Manitoba, you will be working with an account manager here in Austin, Texas, where I am. Or if you're in Ontario or Quebec, you would be in our Boston office, but we certainly would support your projects. And I believe, yeah, GS will absolutely work for Canadian applications.
Sure, of course.
Yeah. Another question is, what is the status of SCHIP in California? And step 2 will begin accepting applications on Monday, and these can be completed now. Funding for steps 2, 3, and 4 has been doubled. So all funding updates and info can be found on selfgenca.com, and that's selfgenca.com. And I will post that on the questions too. For you, Eric, is there a method to monitor each battery cell in a multi-cell battery?
No. In fact, each one of these batteries that we talked about in these case studies are 2-volt cells. So there's no monoblocks here where we would use like a 12-volt battery and try and monitor each individual cell within that battery. Since this is a 2-volt cell, and we use 24 of them to build a 48-volt DC bus in these cases, we can monitor each individual cell for both voltage and temperature. And then we measure current into the 24-volt module, or 24-cell module, 48-volt.
Awesome, thanks. Couple more. For a demand response application, what equipment is required to make the battery demand response work?
Yeah, it can be kind of complex, and it really depends on the size and scope of the project. We're working on a project now in Mexico, and if you're familiar at all with CFE, the utility in Mexico, they are the poster child of demand response, peak demand charges, time of use charges. Any sort of commercial and industrial application down there, they're going to get dinged pretty hard if they exceed a threshold. So our project down there consisted of power conversion, energy storage, and a microgrid controller, which is basically a software solution that it's looking at the demand at all times and and making choices between PV, generator, or energy storage based on the demand of the site and the rate that the local utility is charging at the moment. So it's actually a little bit of a complex piece of monitoring and software, but we've done a few of these before now, and we're really able to narrow it down, get an economic solution that's rapidly deployable and scalable. So we can add one module, add additional modules on top of that for sites that have higher current requirements and higher power requirements.
And then I have two separate questions that we've been getting sort of related. One is about any inverter preference, and a separate is, can you talk a little bit about the economics, especially in comparison to lithium batteries?
Sure. Two really good questions. We're kind of inverter agnostic. As I mentioned, we used SMA here at our site. It was actually the first PV plus energy storage facility in the state of Georgia. But we've also done a lot of projects with Schneider Electric. We've done Outback. We've done Pika. We've done certainly EPC and Ideal on some of the larger types of inverters, larger three-phase inverters. I've done some work with S&C. Really, we haven't found too many inverters that we can't work with. The battery itself, especially this SLR battery, it has a lot of the resiliency of a lead-acid battery in that it can take constant current or constant voltage. We have an ideal charging algorithm that most of the inverters, certainly those big three, SMA, Schneider, and Outback, can easily be configured for optimum performance. And the second question, the price point. I'll leave the pricing discussion more on the CivicSolar side since they're the distributor, but it's very economical, especially when compared to lithium ion. A lot of, I think the stack that you see on this slide that we happen to be on now is on the Civic website right now, about $17,500 for 48 kilowatt hours of energy storage. I think that works out to about $350 per kilowatt hour. I'm kind of going from memory here, but that's the neighborhood. And that's again the full system with the racks and the batteries and the overcurrent protection and safety shields and bus bar covers and all of the complete system. So we'll provide you with a breaker. Simply land your conductors from your inverter charger on that breaker, and as far as energy storages go, you're pretty much set.
Yeah, and for projects of this scale, I love the GS offering the 48 volt configuration because it really is scalable for large projects. And there also is the SLX, the 210 amp hour and the 250 amp hour for the 12 volt cells if you need something smaller. So I think that GS really has a solution that will fit even in comparison with a lithium competitor. And a next question we have about design. This is, yeah, go ahead.
If I could point out one more thing about that comparison to lithium, I'm open to. I sell all of these chemistries. So for the right application, each one of them has the right solution. But if you look at the performance of this battery, there we go. 5,000 cycles at 70% depth of discharge and a 10-year warranty. It's really not that far off from what you would see on typical consumer grade lithium ion. Even some of the better lithium ion batteries they'll give you 6,000 cycles at 80% depth of discharge. Not really that far off from what we're seeing here with a lead acid battery.
Would there be any difference between applications? I mean, well, New York is a good example for lithium versus a lead carbon battery, but would there be any application-based reasons why you would pick one or the other?
Well, we typically use lithium for batteries that require a really high rate of charge or discharge. So when we showed that graph in the opening slides, where there were benefits to the end user, but there were also benefits to the utility and to the transmission grid and the ISO. Really, when we start dealing with the ISO and the utility, and they're doing things like frequency support and voltage or VAR support, these types of applications, rather than a battery that wants to do a daily cycle or maybe 2 cycles per day, where you're going down to a set point and then fully recharging the battery between cycles, they need to be able to sit in the middle of their battery state of charge and discharge as needed. And maybe they'll do 1,000 charges and discharges in the course of a day, or maybe even in the course of an hour when they're doing frequency support. That's really a much better application for a lithium-ion battery. One of the claims to fame that we have is that we have more kilowatt hours of energy storage in orbit than any other manufacturer. There's a great video on YouTube with the astronauts from the International Space Station replacing the batteries for their solar array. And the batteries that are coming out are nickel metal hydride battery, but the batteries that are going in are lithium ion batteries. So if anybody is considering a space application, we'd love to talk to you about that project. But that's the type of product pedigree that we're talking about with our lithium ion batteries.
Wow, that's really exciting, pretty amazing. Another question that was, I think, particularly relevant is design related. So who designs these projects? And I'll speak to that a little bit. Our account managers do design for grid-tied battery backup or off-grid projects. So that's absolutely some conversation you can get started through your CivicSolar account manager. But Eric also mentioned that GS has design engineers on staff for support in that regard too. Another one for you, Eric. Can you mix old and new batteries with the SLR?
I really wouldn't recommend it.
Okay.
Especially if there's a significant time period between the old and new batteries. What happens, especially in the cases where the batteries are all in series, the new batteries will quickly come down to the level of the old batteries. So, it's kind of one of my engineers said it's kind of like changing your oil, but not changing your oil filter. You're still kind of not getting the best of both solutions. So we recommend whenever possible, at least within a string. We do a lot of projects where there are multiple strings, where each string will have its own inverter. In that case, you can kind of stage the approach, but within a single string, I wouldn't recommend using old and new batteries.
Yeah, that's definitely good to note. I like that reference with the oil filter. That's a good way to think about it. So we're getting a little bit low on time. So if anyone has further questions, please feel free to email them to me, and I will either field them to Eric, or I can have one of your assigned account managers get back to you. So thank you, Eric, for your time. This was really, really helpful, and I hope that everyone attended, enjoyed it, and we will have your account managers get in touch with you soon.